Hello guys, I Dipali welcome you all in this video. In this session, I am going to explain about bolded bracket connection. Okay, that is mean that beam to column connection. Okay, as you can see here, this is the beam. Okay, and this is the column. After that, the figure shows an eccentric bolded bracket connection. Okay, this connection is called as a bolded bracket connection. It consists of two bracket plates. As you can see here in this diagram, bolded to flange of rolled steel column. If a load W be applied to the bracket, a load P equals to W by 2 is transmitted to each bracket plate. The line of action of load P on bracket plate does not pass through the centroid of bolt group. The perpendicular distance between the centroid of bolt group and the line of action of load P is called as a eccentricity of load. Okay, after that I have one numerical which is based on the bolded bracket connection. Okay, let's move toward this numerical. The question is like that: a bracket plate connected to flange of column ISHB 350 at 0.674 kilonewton meter. Okay, through 20 mm dia. The diameter is, which is denoted by 20 mm. Dia bolt is subjected to a factored load of 400 kilonewton. Okay, we have to convert it into a newton. After that, at an eccentricity, this distance is called as a eccentricity, equals to 300 mm from center line of a wave of column. Assume the load plane and bolt plane being the same design of connection. After that, we have to know the value of G, that is a gauge distance of a column section from steel table. Okay, with the help of this ISHB 350 at 0.674 kilonewton, the G equals to 140 mm and TF, that is the thickness of flange, that is 1.6 mm, 11.6 mm, sorry. And let us provide 20 mm dia bolts of grade 4.6 and steel of grade 410. So D equals to 20 mm. The diameter is 20 and the nominal diameter is DH equals to 20 plus 2, that is 22 mm. After that, Fy is 250. You have to assume it. Then the Fu equals to 410. FUB 400 Newton mm square. Okay. After that, we have to calculate first the H distance. The formula for calculating the H distance is 1.5 dn. 1.5 into nominal dia is 22. So we get 33. Say it as a 40 mm. Second, we have to calculate minimum pitch, that is 2.5 D. 2.5 into 20, we get 50. Say it as a 100 mm. In this problem, pitch, we have to consider the pitch in between 80 to 100, so that then and only then we can say that this problem is safe, okay, or this numerical is safe. After that, we have to calculate the value of KB equals to, in that first one is E upon 3dn, 40. The E we are already calculated, that is 40, and 3 into dn, that is a nominal dia. So after calculation we get 0.606. After that P equals to P upon 3 dh minus 0.25. The minimum pitch is 100. So 3 into 22 minus 0.25. After calculation we get 1.205. Third one is FUB upon FU. 0.976. Okay, and the last step is for calculating the KB equals to 1. We have to assume, we have to take the least value from these 4 values. So KB equals to least of all. .606. After that, the fourth step is design strength of bolt. That is, we have to calculate the bolt value. We called it as VDSB or VSD. In that, first we have to calculate the design shearing strength of bolt. Bolt in single shear. VDSB equals to FUB upon under root 3 into 0.78 pi by 4 into d square upon 1 upon gamma MB. We know the value of FUB, we know the value of diameter, but we don't know the value of gamma MB. The value of gamma MB is 1.25 in IS 800 2007, page number 30. There one table is given. Okay, so we have to put this value in this equation. FUB equals to 400, already given. Okay, and 0.78 into pi by 4 into 20 square into 1 upon 1.25. After calculation we get VDSB equals to 45.273 into 10 to the power 3 Newton. Okay, this is the value of design shearing strength of bolt. Now second one is design bearing strength of bolt, which is denoted by VDPB. Into D into T FUB. In this equation we have to put the thickness, that is thickness of flange and thickness of bracket plate. List value of these two thickness. Thickness of flange is 11.6 mm and thickness of bracket plate is 19 something. So the minimum is thickness of flange. So we have to put 2.5 into 0.606 into D is 20. Thickness of flange is 11.6 into 410 upon 1.25. After calculation we get the value, that is VDPB equals to 115.285 into 10 to the power 3 Newton. Okay, after that we have to choose the value, that is a list of these two value VDSB and VDPB. We get the value of design strength of bolt, that is a bolt value. List of two value. Okay, that is 45.273 into 10 to the power 3. Okay, after that we have to calculate the moment. Fifth step is moment. For calculation of moment, load into perpendicular distance. In this diagram, as you can see here, this is the load P and this is the eccentric distance. We called it as a perpendicular distance. Okay, P into E, we get the moment. So P equals to 400 into 3, 10 to the power 3, and the eccentric distance is 300. Okay, after calculation we get 120 into 10 to the power 3 Newton mm. After that, the sixth step is, 1 minute. The sixth step is to find number of bolts in the bolt group. For calculating this, we have one formula. Let us first we have to consider, or we have to provide, let us provide bolt in two vertical rows. Or vertical lines, you can say that the rows or vertical lines. In that, first we have to calculate the number of bolt required in one vertical row. For that we have a one formula, that is under root 6m 6 into moment upon 2 into pitch distance into design shearing strength of bolt or strength of bolt, that is VSD. We are already calculate the value of moment, value of minimum pitch or value of design strength of bolt, or we can say that the bolt value. Okay, after putting this value we get the number of bolt, that is 6 into 120 into 10 to the power 6, 2 into 100. VSD is 45.273 into 10 to the power 3. Okay, after calculating we get the number of bolt, that is 8.91. Say it as a 9. Okay, this number of bolt in one vertical row. So we have a two vertical row, as you can see here in this diagram. There is one vertical row and this is the second vertical line. Okay, we have to manage this number of bolt in these two vertical lines. Okay, so for we are already calculated for the one vertical row, that is a 9. So after multiplying the 2 we get the for the two vertical lines. Okay, so B equals to number of bolts required in two verticals row, or you can say that the bolt group. Okay, after that 2 into 9 we get 18. Thus provide 18 bolts of 20 mm dia on each bracket plate. With 9 bolts in each group. Sorry, or you can say that each row. Okay, after that the next step is for check the connection, that is the sixth step, check the connections. The next step is check the connection. Okay, now let's move toward the diagram. This is the load and this distance is eccentricity, that is which is denoted by the E, which is already given. The value is 300. Okay, after calculating the number of bolts in one vertical row is 9. 1 2 3 4 5 6 7 8 9. Okay, after multiplying this 2 for two vertical lines we get 18 bolt. Okay, in one row there are the 9 bolts. Okay, and the bolt to bolt distance, that is the center to center distance of bolt, that is which is called as a minimum pitch or pitch, which the value is 100 and the edge distance is 40. Okay, similarly there is a gauge distance which is denoted by G. Okay, after calculating from the steel table we can calculate it as a 140 mm. Okay, so this is the 70 mm and this is also the 70 mm. In that first calculation for R1, this is the center of gravity, that's G is center of gravity. G denotes the center of gravity. Okay, the center distance between up to the G is R1, and this is for the R2, and this is for the R3, this is for the R4. Okay, R1 equals to, by applying the Pythagoras theorem, we can calculate the R1 equals to 100, 100, 100, 100. Okay, this is the 400 square plus this distance is 70. Okay, after calculation we get 406.08, or you can calculate it with the help of this triangle also. This is the R1 and this gauge distance, the half gauge distance is 70, and 1, 2, 3, 4. Okay, 100, 100, 100, 100. This is the 400. Okay. After calculation we get the value R1 equals to 406.08 mm. Similarly, we can calculate it for the R2. This distance 100, 100 and 100. Okay. That is the 300 square plus 70 square. After calculation we get 308.06 mm. R3 200 square plus 70 square. After calculation we get a 211.9 mm. R4, this is R4 100 square plus 70 square, 122.06 mm. Due to horizontal, the R5, that is R5 equals to, due to the horizontal, the half of gauge is 70, so this distance is 70. Okay, from this R5, R1, R2, R3, R4, R5, the R maximum equals to maximum value of the all of the above, maximum value of all the values, the above values. Okay, the R max equals to 406.08. After that, the summation of R square. Okay, this R1 is similar for the this bolt also. So 1, 2, 3, and this is for the 4. So 4 R1 square plus 4 R2 square. Okay, 4 R3 square plus 4 R4 square, and the R5 is for the 2 R5 square. Okay, after putting the value of R1, R2, R3, R4, R5, we get the summation of R square, and this is required for the F2, that is a force in bolt due to twisting moment. Square 4 into R2 is 308.68 whole square plus, and R3 is 211.9 whole square plus R4 is 122.06 square plus 2 into 70 squares. The summation of R square, after calculation this equation, we get 1.288 into 10 to the power 6 mm square. Okay, now after that we have to calculate the F1. First one is F1, that is a force in bolt due to direct shear. Bolt due to direct shear. This direct shear is denoted by P. Okay, that is a P. After that, for this the formula is P upon N. That is, the load is 400 into 10 to the power 3 upon number of bolt in 2 rows, 18. Okay, after that 22.22 into 10 to the power 3 Newton. After this, we have to calculate the F2, that is the force in bolt due to twisting moment. Okay, for this the formula is like that: m upon summation of r square into r max. This m is for the moment. Okay, moment equals to 120 into 10 to the power 3 into summation of r square. We are already calculated 1.288 into 10 to the power 6. R max equals to 406.08. After the calculation, we get 37.83 into 10 to the power 3 Newton. Okay. After that, we have to calculate it C, that is a cos theta. We know the, as you can see here in this diagram, the R1. Okay, and this is the theta. This side is opposite side and this side is adjacent side. This is the hypotenuse. Okay, this distance is gauge distance by 2, and this for the opposite side, the cos theta equals to adjacent side upon hypotenuse. Okay, after that the adjacent side is gauge by 2, that is 140 by 2 equals to 70, and the hypotenuse is R1, 406.08. After the calculation, we get 0.172. Okay, the next one is D equals to resultant force. We have to calculate the resultant force also, that is Fr. For that, we know the formula, that is under root of F1 square plus F2 square plus twice F1 into F2 cos theta. Okay, we know the value of F1, that is 22.22 into 10 to the power 3 whole square. We are already calculated value of F1, F2 and cos theta. F2 is 37.83, this value, into 10 to the power 3 Newton, plus 2 into F1 is 22.22 into 10 to the power 3, 37.83 into 10 to the power 3. Cos theta is 0.172. After the calculation, for resultant force equals to 47.053. Okay, into 10 to the power 3 Newton. This value is greater than the VSD, that is the shearing strength of bolt, that is 45.273 into 10 to the power 3 Newton. Hence, this assumption is unsafe, so we have to increase the number of bolts. Okay, so let us provide 10 bolts in each row. So vertical row, the number of bolts required in two verticals row equals to 2 into 10, so 20. If the resultant force is greater than the design strength of bolt or the bolt value, now then and only then we can say that this is the unsafe. Okay, if the resultant force is less than VSD, okay, that is the bolt value, so then and only then we can say that the this assumption is safe. Okay, if the unsafe, hence the assumption is unsafe, we have to increase the number of bolts. In this numerical, we assume 9 bolts. So after that, the even number we are suggested that the for number of bolt, that is the 10 bolts in each vertical row. So the number of bolt required in two vertical row, that is a 2 into 10 equals to 20. Okay, in bolt group n equals to 20. So for this number of bolt we are we have to calculate this same procedure, this all same procedure for number of bolt in each row, that is a 10. So for two vertical row the number of bolt is 20. After that, first we have to draw this diagram. Okay, let's we have to arrange the each 10 bolts in each row. Okay, this distance is gauge distance. Okay, and this distance is eccentricity or eccentric distance, and this is the load P. 1 2 3 4 5 6. So check the connection. That is, this is the center of gravity, that is G. From this first bolt, for the first bolt, that is a R1, and the second is R2, the R3, R4 and R5. These are the distance up to the center of bolt from center of gravity. Okay, so for the first calculation, R1, can say that this is the R1 and this distance is the half of gauge distance, that is a 70, and this distance is 100. Okay, so 100, 1 2 3 4 5. Okay, the 500, this is the distance is 450. 450 square plus 70 square. After the calculation we get a 455.41. Okay, R2 is like that, 350 plus 70 square, we get 350 plus 350.93 mm. After the calculation of R2, R3 equals to 250 whole square plus 70 square, we get a 259.61 mm. And R4 equals to, we have to calculate the similar values for R1, R2, R3, R4, R5. Okay, 150 into 70 square, 165.53 mm. And R5 equals to 50 square plus 70 square, we get a 86.02 mm. The maximum value, that is R max, equals to, from these above values, that is 455.41. This value is required for the force in board for twisting moment. Okay, and the summation of R square equals to, this R1 is up to the distance of this, okay, this bolt also. So 1, 2, 3 and 4. The R1 equals to R, summation of R square equals to 4 R1 square plus 4 R2 square plus 4 R3 square plus 4 R4 square plus 4 R5 square. After putting this R1, R2, R3, R4, R5, these values, okay, we get a summation of R square, that is 1.74 into 10 to the power 6 mm square. This is also required for the force in bolt due to for twisting moment. Okay, this F1, we have to calculate the F1 first, that is for the direct shear, that is the formula is P upon N. The P is 400 into 10 to the power 3 upon 20. So we get a 20 into 10 to the power 3 Newton. And the second, the force in bolt due to twisting moment, that is M upon summation of R square into R max. We get a moment equals to 120 into 10 to the power 6 into R max is 455.41. This is also in mm. Okay, and summation is R square is 1.74 into 10 to the power 6. After calculation we get a 31.407 into 10 to the power 3 Newton. Okay, and the next is C equals to cos theta. The adjacent side is 70 and the opposite side hypotenuse is 455.41, that is a R1 with 0.154. Okay, after that we have to calculate the resultant force. For that the formula is like that, summation of F1 square plus F2 square plus 2 F1 F2 cos theta. After putting this value, that is F1 equals to 20 into 10 to the power 3 Newton, that is a whole square, plus F2 31.407 whole square, 2 into F1 is 20 into 10 to the power 3. into F2 is 31.407, sorry, it's also 1 into 10 to the power 3 into cos is 0.154. After calculation we get a 39.747 into 10 to the power 3. This resultant force is less than the design strength of bolt, that is VSD, that is a 45.273 into 10 to the power 3 Newton. Then and only then we can say that our assumption is safe, or numerically safe. Okay, thus provide 20 bolts of 20 mm phi on each bracket plate with 10 bolts in each row. Okay, thank you, bye bye.